Hello, sir.
Hello?
Sir, audio clear ആണോ?
Yes.
Yes.
Fine.
Sir, ഒരു സെക്കൻഡ്. ഒരു ഇയർഫോൺ വെച്ചിട്ടാണോ ഇങ്ങനെയാണോ ബെറ്റർ എന്നൊന്ന് നോക്കണമായിരുന്നു.
Okay.
സർ വാട്സാപ്പിൽ മെസ്സേജ് അയച്ചാൽ മതി.
Okay.
Hello, good morning. Hello, sir.
Hi, good
Good morning. Good morning, ma'am.
morning,
Good
ma'am.
morning. Very happy to join with you. Congratulations.
Okay, thank you, ma'am. Thank you, ma'am.
Okay. All the best. Okay.
Yes, thank you, ma'am.
Okay, Mole. Wonderful music. Wonderful welcome music. Okay. Ajna, can you remember me? Ajna?
Yes, ma'am, I can. How can I forget you, ma'am?
Yes. And this is your Women's College.
Yes, ma'am.
Can you remember
I
me?
think-
Have you
Yeah,
seen
sure, ma'am. I can remember you.
Women's
Yes,
College?
yes. You are principal.
Okay. Okay. Yes, go on.
Yes,
Go
yes.
on. Okay. Okay.
Sure, ma'am, sure.
All the best.
Thank you, ma'am.
Hi everyone, we will be starting the webinar within short time, in around 5 minutes. Hope you all will be patient till that.
Hello, Shikhi and Dr. Bijimon. Hi.
Okay, ma'am, maybe there is some network issues. Let me repeat once again. Yes, we will be starting our webinar within short time. Yes, please be patient for around 5 minutes.
So, sir, is the audio clear? Vinod sir?
Yes.
Okay.
Yes, yes.
Thank you. So, good morning, everyone. I'm super excited and happy to see each of you in this virtual online platform. So, finally, the day has come. Today, we are all here to be the part of the webinar series Math Ecstasy, an online odyssey through mathematics, organized under the initiative of Dr. Vinod Kumar P, Assistant Professor of Department of Mathematics, TMG College, Tirur, Kerala, in association with the Math Aspirants WhatsApp groups and joining hands with Career Development Center, Perambra, Kozhikode. The invited talk on artificial intelligence, myths and realities will be led by Dr. Chandrasekhar Lakshmi Narayan, Assistant Professor, Department of Computer Science and Engineering, IIT, Palakkad. This webinar is the second one in this series. The previous webinar on role of mathematics in cyber security, organized under the same team, got a wide appreciation and serves as a fuel for this one too. I hope many of you have also attended the previous one. So mathematics binds you, me, and everyone who is present here, and it's a great thing. Okay, disregarding of our place and country, job status, etc., etc. It is such a wonderful unification, and it's really great. Like in the previous time, the reach is good this time also, and it's glad to share with you that there are 2K plus registrations, out of which 1.2K plus are UG/PG students, and we have registrations from different countries around the world: Pakistan, Iraq, Nepal, Bahrain, Sudan, Ghana, Nigeria, Philippines, Bangladesh, UK, Morocco, Egypt, Austria, Libya, UAE, US, etc. And obviously from all over India, all states. And the creative hands behind this event is a simple team of teachers and students utilizing three very rich and active WhatsApp groups, namely Math Aspirants, under the guidance of Dr. Vinod Kumar P. Vinod sir is the key person taking great effort behind all these. His online exam series conducted through Google Forms was noticed nationwide. He is restless and continues his hard work. 15 online problem solving sessions were conducted, in which students from premier institutes in our country participated, as well as the faculties were from very good universities around the world. With all my respect and love, I would like to invite sir to share your thoughts to us. Vinod sir, please welcome.
Good morning, everyone. Am I audible to you?
Yes, sir, audible.
Okay. Good morning. Hearty welcome to all of you for the today's national webinar on artificial intelligence. I'm very happy that we have a mass participation from various parts of India and abroad, budget areas, and also from different stratas of the society. I remember my beloved teachers in this occasion who guided me. The Math Aspirants WhatsApp group, started in 2017, now became one of the best gathering of maths lovers and students. During these lockdown days, we started online test series and online live problem solving sessions to help the math students. These initiatives were well accepted by students preparing for JAM, NET, GATE, and other competitive exams. The webinar series Math Ecstasy was started with the first talk by Dr. Abhishek Adhikari of Presidency University, Kolkata on August 15, 2020. Today, we have the second webinar in this series, Artificial Intelligence, Myths and Realities, by Dr. Chandrasekhar Lakshmi Narayan of IIT Palakkad. So we are blessed to have an eminent personality as resource person. I express my sincere thanks to him for accepting our invitation and joining hands with us. I would like to thank Professor Abhishek Adhikari, Presidency University, Kolkata, Professor Ampat Vijay Kumar, Emeritus Professor of Cochin University of Science and Technology and Vice President of Ramanujan Mathematical Society, for their support in my initiatives. I extend my sincere gratitude to Dr. Sharath Shashi of IIT Palakkad, Mr. Harry Anthony, for their helps in arranging this webinar. I thank the manager of Career Development Center Perampra, Sri Rajivan sir, and the staffs of CDC for hosting our webinar with the technical supports. I would like to thank Dr. Bijuman Ramalayathan, Associate Professor of Mathematics, Mahatma Gandhi College, Iriti, Kerala, for the wholehearted support in all occasions. I extend my thanks to my beloved students, especially Ms. Dia Rose Johnson, Ms. Anne-Marie Tony, and Ms. Arjuna for the creative ideas, dynamic presence, and support throughout my initiatives. Finally, I extend my sincere gratitude to every member of Math Aspirants WhatsApp groups and well-wishers. Hope that the session ahead will be an intellectual feast for all of us. Once again, a warm welcome to all of you to this program. Thank you.
Thank you very much, Vinod sir. Your words are like a blessing for each of us. And now let me call Dr. Rajivan sir, Director of Career Development Center, Perambra, to share a few words with us. Please welcome Rajivan sir.
Thank you. Hi friends, and Vinod Kumar sir. I am very happy to invite one and all to participate in this program. Career Development Center is a new venture of Kerala government. The main objective of this organization is to provide necessary support to all in taking their career decisions. This is the flagship project of the Career Development Center Perambra, which is providing regular training to students to get admission for the PG program in the Centers of Excellences in India. We are very happy to organize this webinar and happy to invite one and all. The subject, artificial intelligence, myth and reality, is a very relevant subject of this time because artificial intelligence is influencing the day-to-day life of human beings today. The character of the future employment market will be determined by artificial intelligence and related subjects, I think. I respectfully invite our honorable guest and the speaker of the webinar, Dr. Chandrasekhar Lakshmi Narayan, Assistant Professor, IIT Palakkad, on behalf of Career Development Center, Maths Aspirants Group, and National Employment Service Department. Okay, thank you.
Thank you very much, Rajivan sir, for your words. By the way, let me remind you that by the end of this webinar, you will be getting a feedback form link. And once you fill the feedback form, you can get the e-certificates. So please don't forget to fill the feedback form. Okay, now it's time to invite our speaker, the important person of our webinar. Let me give you a small bio about our chief guest. Dr. Chandrasekhar Lakshmi Narayan. He is currently working as an assistant professor in the Department of Computer Science and Engineering, IIT Palakkad. He obtained his PhD from Indian Institute of Science and has several publications. His areas of research include reinforcement learning, stochastic control, and deep learning. So, with all our special love and respect, let me invite Dr. Chandrasekhar Lakshmi Narayan to take our session. And everyone, you can show your love in your chat box for our speaker. So, welcome, sir. Please welcome.
Thanks everyone for attending the session. So I just start by taking an opportunity to thank Dr. Sharath, through whom I was able to know Dr. Vinod, and thanks for putting up such a great effort, because most of as much as we are doing research and teaching, etc., it's much more important that there are other channels of dissemination of information so that everybody gets included and everybody understands what's happening. Not all of us are cricket players, not all of us are chess players, not all of us are tennis players, but we do get to see chess, tennis, and cricket in TV, and then we are able to appreciate why something is happening. It's very nice to know that maybe I don't know, maybe we will not be playing like Messi, but then we can copy some of the tricks that in the football game that we are playing, right? And that enriches our life, and we feel connected, and the world feels connected. So this is a very, very important step, right? Dissemination of information. So I would like to thank Dr. Vinod. I would also like to thank Dr. Rajivan and Miss G.R. Rose Johnson for the poster, and Arjuna for the introductions. So what I will do is I will be joining, currently I am joining via my cell phone. I will join via the my computer and try to share my screen so that I can, and you can tell me whether you are able to see the presentation.
Okay, sir. Sir, kindly please switch on your video.
Okay, sure. Yeah, sure. So I'm slightly less on charge, so that's why I'm kind of playing. I will be switching on the video. Just a second. So if this is fine. Can you see me? Now I'm going to mute my mobile phone, but it's going to present the screen. Yes. Can you see the screen?
Yes, sir. It's visible.
Okay. So yeah, I was just muting my phone. So now everything is fine, right? Hello.
Yes, sir. You are audible.
And the
And
screen is visible.
screen is also visible. Yes.
Okay. Okay. So okay. So yeah. Let us get
But
started.
excuse me, sir. The sound is little bit low comparing to previous time.
Okay, so I will do one thing. Then I will try to transmit the sound through the my phone, and yeah. Now is this audible?
Now is this audible? Now is this audible? Now is this audible?
Oh, I think. Is this audible now?
Yes, sir. Sound is increased.
Okay, so let me see whether. Oh no, this is. Does not have cancellation, so I should. Speaker. Yeah. So is this okay now?
Yes, sir. It's okay. And the entire screen is getting presented. Yeah, now the PPT is visible.
Yeah. Because I was trying to do both, right? Yeah, fine. So now, yeah. So let us. So I'm just the audio is over phone, and the presentation is over the computer. So that's fine. Let us get started. Okay. So yeah. So what we think AI is and what actually AI is. This is what I want to get to in this talk. Okay. So in layman terms or simple terms, when we say AI, we kind of think that it is something related to the brain, it is something related to cognition, or it is something related to neuroscience. We think a lot of things. Okay, so because the word intelligence is being put in AI, okay, so that's something that we think. But what it actually is, the state-of-the-art AI systems can now do image tagging. It can, meaning if you show a photograph, it can tell parts of the photograph, saying that there is a dog in this photograph, there is a bus, there is a person, there is a flower pot, or so on and so forth. Okay, so they can do that. They can drive vehicles on their own. Okay, that's possible today. And they are able to do human speech, meaning they are able to converse with human beings, and then they're able to do that. They're able to play chess. It is not that they're able to play chess. It is also the fact that they can learn to play chess on their own. Okay, this is a very significant thing, that previously we were having computer programs which were not really AI. They were able to play chess, but then now we have a system that's learning to play chess from scratch. Okay, and they can also play Go. Go is a much harder game, much more strategically involved game than chess. Okay, they can also do that. So what is the difference between what we think it is and what actually it is? That's what this talk is about. Okay, so this is a quote by Feynman. So what he says is that it turns out all you need to do when you read or hear something that sounds smart is try to translate it back into ordinary language, or better yet, have the person explain it for you without using any scientific jargon or terms, and see if it still makes sense. Okay, Richard Feynman is a very famous theoretical physicist, a Nobel laureate, and also known for his simplifying, for his ability to simplify complicated ideas. Okay, so we will go with this kind of an attitude with inside this talk. Okay, so if you don't understand every slide, that's fine, but as long as you can understand the overall philosophy or overall approach of what's happening around us in AI, that's enough. Right, the individual topics themselves you can go and pick up. There are separate course notes, lectures available online. So this talk is not a substitute for a full-fledged course on machine learning or AI. But what this talk is, how can you relate AI, the ideas of AI, with what you know already? Okay, that's my effort here. Okay, so yeah, so the setup that bridges the layman view of AI, or the simple term view of AI, which is like, you want to create intelligence, to actually building the state-of-art AI systems. Okay, so when we say state-of-the-art AI systems, we mean that these are actually engineering systems. Okay, these are not something that's in imagination. These are not just some theorems which are there in the paper and they are not being translated yet. That's not the case. Okay, so these are actually practical systems that people are building, and all the tasks listed here current AI systems can do. Okay, and there is a mathematical foundation of probability and decision theory put together in the in the paradigm of what we call as rational agents, that's responsible for this shift. Okay, so that's the bridge. Okay, so that is something that we have to keep in mind. So we will see how that this probability and decision theory and mathematics itself plays a key role, right? Ultimately, we have to engineer systems. Engineering systems meaning writing code. Writing code means what? Writing mathematical statements, trying to compute things, right? Calculate things. That's where mathematics comes. Okay, and all of this is without mathematics, all of this is not possible. None of this is actually possible. So so we will look at slowly how probability comes and plays a role. Before that, we will slowly build onto what we mean by AI. Okay, in simple terms. Okay, so AI in popular culture. So we know either the iRobo movie or the Yenthiran movie, which so where there is a robo and then the robots take over the world, etc. Okay, but if you actually look at, I mean, one of the dialogues in the movie Indiran, right? So it says I am Chitty the Robo, speed 1 terahertz, memory 1 gigabyte. Okay, this is just telling that it's a big computer. Okay, a lot of memory, a lot of speed, that's fine. Okay, just with memory and speed alone, we are not going to be able to build AI systems. Okay, that's a big computer. So this is like saying, so I would like to share some personal anecdote. So I have a brother who is significantly younger than me. He was in school when I was in college, actually. So, and he was thinking that when you go to, as you go higher and higher up, you will be learning something like 5,000 tables and 7,000 tables. Because at school, he was learning tables. So his simple extrapolation was, somebody in engineering will be doing 7,000 tables. Okay, so that's not how it happens.
Excuse me, sir.
It's
Sir,
breaking?
no, it's not breaking. Some of them saying that screen is not visible. I would like to request those people to pin the presentation of sir. You can see the presentation in the people. Please pin it so that you can see the presentation. Okay, thank you, sir.
Yeah, okay. I hope, so you are able to see it, right?
Yes, it's because we can pin it. That's all, sir.
Okay. Sure. Okay. So the thing is that, so yeah, again, sharing the anecdote. So people think that, tend to think that you are kind of doing something really, really big, right? A big computer will not give you artificial intelligence. Okay, it's not just big computers. So when you ask students, okay, what's artificial intelligence? So this is some of the student responses that I got from the class, the AI class that I teach at IIT Palakkad. So they say that intelligence is the ability to assess conditions and act accordingly such that it rewards, adapt to new situation from previous experience, solve problems with seemingly complex solutions via trial and error or application of knowledge from prior experience, perform well in new related tasks. Okay, all these are actually even without me teaching them. Okay, this is the response that I got from them when they are in their first class. Okay, so you can think that these are actually what people even from common experience can tell about what AI is. Okay, so a couple of things. So all these things known as experience, right? Experience is basically data. Okay, previous experience is past data. This is where data is playing a huge role. Data science and AI and machine learning, all these keywords we keep hearing together, but all that previous experience is data. Okay, and we have to, be able to do problem solving. Okay, there is we will be seeing some amount of problem solving in this lecture. Okay, in this talk, where problem solving comes from, and generalization. That is, you see some tasks previously, and then some similar task is given. You would want to do well in that similar task. Okay, and experts code itself, it says that AI is a science of common sense, and AI has to do with smart programs. So let us go and write some smart programs. Okay, so it's not just going to be possible like you can just go ahead and write smart programs. We will see why that's not possible in some time. Okay. Okay, so let us first differentiate between programs and smart programs. Okay, what are programs? So standard program is IRCTC booking. Say you can calculate the tax, or you can do some bank transaction. All these are programs, right? We have all the modern computer revolution has brought us all of these things to our doorsteps, where if you have a sequence of commands, you can code it up in a computer and then the computer can do it for you. Okay, when you are saying smart programs, you have something like self-driving, you have playing chess or speaking, conversing in natural language with human beings. These involve non-trivial problem solving. Okay, so the keywords is the common sense is that you have to learn, you have to adapt, and then you have to respond to new situations. Okay, so this is the difference between when we say programs and smart programs. Okay, so let us just take a step back and then let us put us back in the 1960s or 70s, right, where computers were the new thing. Okay, so what were the natural questions? Oh, what is a computer? What are its components? Why do we need them? Right, and then we have to understand the difference between a computer and a calculator. Both of them are electronic components, but what is the understanding? The understanding is that computer is not a calculator. All of us know it, right? So similarly, what we want to know is that AI is not just computers. Just like computers are not calculators, artificial intelligence is not a computer, just a computer, right? Commonality between calculator and computer is both of them have the same kind of electronic components, right? You have the same kind of electronic components. You will have some chips. Everything is made of the AND gates, NAND gates. If you look into a computer and a calculator, you have similar parts. Okay, so the only sophistication is on the higher side, which is computers are programmable. Okay, you can program computers to take a sequence of commands, and then calculators are not programmable. So when you are saying we have to ask a question: are computers
Excuse me, sir. Audio is breaking, I think. Or maybe you are mute, sir.
Oh, okay, sorry. How long did the audio go away?
Just 1 or 2 sentences maximum.
Okay, so yeah, so what I was saying is that computers are intelligent. Are computers intelligent just because they are programmable? Okay, so the aim is we have to understand to at least this much, that just like calculators are not computers, we have to understand that computers will not be AI. Knowing to program does not mean the same thing as writing smart programs or developing artificial intelligence systems. There are again extra components, extra sophistication, extra concepts that are required. Okay, so let us take a look at IRCTC booking. Okay, so how do you do it? So if you are to do it manually, okay, you will walk up to the station, you will fill a form, and then you will present it to the person, right? Whoever is booking the ticket, and then the person checks whether the ticket is available between station A, the starting station, and ending station. If it is available, they will issue the ticket, and then they will reduce the amount of seats available on their side. If it is not available, they will say, sir, it is not available. Okay, you can extend this to say, if you're a ticket booking for 5 people and then only 3 tickets are available, then the conversation goes like, okay, do you want to book for 3 people and then the rest 2 people, so on and so forth. So ultimately the point is that the number of cases, right, if this, do that, if this is the case, do this. So all these things you can code, because the number of cases are very, very less. Okay, that's the fundamental point. Okay, so so the curious question here is that, so we want to make a computer drive a car on its own. We want to make it identify the objects in a photograph. We want to make it to converse with human beings. We want to make it play chess, play video games. Okay, so can you write smart programs like the way you have written it for IRCTC? Okay, is it just possible to just say that if it is like this, do the steering this way? If it is like this, like some other situation, can you just press the brake? Is it possible to just write it as if then else loops? Okay, see, some of these things. One other important thing that you have to know is that if you ask a person how will you do the IRCTC booking manually, they will know. Okay, if you ask a person how do you drive a car, we ourselves do not know, right? We ourselves do not know how to talk about it as a sequence of commands, right? So this is another important difference. Okay, so I would also want to make one small update. So the charge at my side is reducing. So I might have to switch over from my computer to the my mobile phone. I hope the power will be back in another 15 minutes. That's what they said. So let us see anyway. Yeah. So some of the successes of AI, right? So no, we will be seeing the, so you are not seeing the PPT. I think you should be pinning my other email ID. Yeah. So yeah, some of the successes, we are actually having success. We are having, we are having AI systems that can solve this ImageNet challenge, which has 1,000 object categories, and it is able to train with a data set, which is 1,000 categories, 1,000 example images per category. And it's able to actually tag, okay, the objects in the image. This is something that we can do now. Again, so we have the Google. Oh, yeah, you should. Okay. So you should be pinning my, see, there are two IDs of mine. One in which I am talking, the other one is in which I am not, you will not be seeing my audio. Okay. So, on video. So that's the one that you are supposed to pin. Yeah. So the successes, so these are the successes. And then you have Google Duplex. Okay. And we have AlphaGo, which is Go player. And then we have cars that can drive. Okay. So what is the challenge of smart program? Okay. I'm going to give a very simple, shocking news. Okay. Suppose I give you a free examination. There are 100 questions in the exam, and each question has only 2 choices. Okay. 100 questions, only 2 choices. If you give me the right question answer sheet, any seat that you ask me, I will give you. Okay. So suppose I give you this this condition, right? Is it possible to take this examination and succeed? Okay. So even though it looks like you have multiple attempts on this question paper. Okay. Is this an easy test? The answer is no. This is not an easy test, because there are 2 to the power 100 possible answer sheets, right? Choice A, first answer only requires 2 choices, right? And then 2 questions, 4 choices. So it is 2 into 2 into 2 into 2, 100 times. So what you have is that you have 2 to the power 100 kind of question papers, answer sheets that are possible. Okay. So this is another issue. Okay. So the other thing is, so now the point is this. So if you look at the number of possible positions in a game like Go, right? So the number of possible positions is greater than the number of atoms in the universe. Okay. So is it possible to write program to cover all these possible cases? Okay. It's not possible, right? So you cannot say that if there are so many number of so many choices possible, you cannot just code like as you did for IRCTC. You cannot say if the board position is this, move this. If it is this, move that, right? It's simply not possible. Okay. So the other thing is AI should respond to unseen situations, which is basically saying the combinations are too much that every game of chess is a new game of chess. Okay. You are not going to see those combinations before. So it's not possible to memorize also. Okay. You can say that, okay, fine. The combinations are new. What's the great deal? The point is you can memorize it. Memorizing 5 games of chess is not enough. Or even memorizing all the chess games that are there, and then you will think that you will get the moves right. You will not. Okay. So this is another issue. So we have to understand that these are the basic challenges. So we will have to go to a setup where we will see how to use the probabilistic and decision theoretic setting to go ahead and build these agents. Okay. So how do you write smart programs? Okay. The past approaches to AI. Okay. So what people were doing was to do, you have to think like human beings. This is how people were trying to approach AI. So, but in order to think like human beings, it's not possible, because we are made of biochemical components and computers are made of electronic components. And in order to fly, you need not mimic the bird exactly. You need wings, but you don't need flapping wings. Okay. So essentially, we have to understand the problem. It's not really important. It's not necessary to copy the solution. Okay. And they said that we have to act like human beings, but then the issue is that to err is human, right? Human beings are prone to mistakes, and if you are going to act like you build computer systems, better not to do them so that they act like human beings, because we are doing mistakes, and we are building machines so that we avoid mistakes. And the other thing is thinking rational, which is to say that, if I know all the facts, then I will be able to think for myself what the new fact. Meaning, first fact is I know pandas are cute. Second fact is this Po in Kung Fu Panda, it is a panda. Then I say that, okay, fact 1 plus fact 2 put together, the fact 3 is Po is a cute panda. But the thing is that, again, you hit this combinatorial explosion, where if there are 100 facts, each fact can be true or false, right? So you have to remember the 2 to the power 100 possible combinations. So you cannot really build a fact-based system. Okay. So, so this is one issue. So the other issue is, so what is known as strong AI versus weak AI, where the strong AI says that if computers can imitate human beings, right, by conversing with human beings, then we have AI. Okay. And the weak AI position says that, suppose there is a room, okay, which is called the Chinese room experiment. Okay, instead of a computer, instead of an AI, I as a person, I am sitting inside. Okay, and I know that computers, finally, artificial intelligence is going to be made by computers, is going to be achieved using computers, and computers understand commands. Okay, so what I do is I take all the commands and then I process it manually by my own. It will be very slow, but it is fine. I will process it. So what I can do, any AI, which suppose I build an AI which can talk in Chinese, right? Which will accept input in Chinese and produce output in Chinese. I, as a human being, I will be able to replicate, right? I will be able to replicate this AI as a human being. I will be sitting inside, and instead of the computer, I will be running the commands. Okay. But I really don't understand any Chinese, even though I can accept Chinese input and produce Chinese output. I don't understand any Chinese, and that's an issue. Okay, so you really do not, you really cannot say that we have understood or we have become intelligent, right? So what we are actually looking at is what is known as the rational AI approach or rational agent approach, where each AI task is defined and you write a program, smart program, to solve the task. Okay, running, driving car, playing chess, speaking with humans. Each of this is a task. So you identify the task, and for that task, you will write a program that will solve the task. Okay, this is all that we can do. So, a small request. So I think I have to go on to my, the mobile phone, because the power, I think, is quickly draining in my laptop. So I have to switch off my laptop and I have to go to my mobile phone. I will be sharing the presentation via my mobile. So yeah, this is a total last minute thing. They say that usually power goes, it comes within 15 minutes. It has not yet come. Okay. So what do I do here? Let's see. On from here. Yeah. So just going to.
Okay, everybody, please be patient. Sir will be back soon.
Yeah. So you are able to still see me, right? I hope the power is back in another 5 minutes. They promised that it will be back by 12. I have this presentation. Okay. So, yeah. So do you have your email ID?
Yes, sir. Pardon?
Do you have yeah, can you tell me your email ID?
Which email ID, sir?
So your email ID, whichever is your email ID, personal email ID, so that you can just play the presentation from that side, and I can just keep talking and walk through the slide.
Okay, sir, let me contact Vinod, sir. Vinod, sir, is giving the email ID, sir. It is in the chat box. Shall I read it, or can you?
Yeah,
see?
can you just read it for me? Just a second.
Sure, sure.
Yeah. Yes.
It
Can you
is
please?
okay. In small letters, it is Vinod Unical. VINO.
Oh yeah, unical@gmail.com. Okay.
Yes, it's
That's okay. So yeah, I hope the power still kicks back. Yeah. So I can maybe pin. Yeah. So yeah.
you are visible, sir.
Dr. Vinod. Yeah, Dr. Vinod, can you do you have the presentation? Hello.
Yeah, yes, sir. Yes, sir. 1 minute.
Yeah, sorry. I think you can just put it, and then as I keep saying, next we can go to the next slide.
Okay, 1 minute, sir.
Is this okay? Because I have to just put it somewhere here.
Chandrasekhar, sir, for me, your video is rotated 90 degree. I don't know what about others. The previous
Now
one was
yeah, correct.
now
So I
it's
was
okay
putting
for
the
me. Yes.
yeah. No, I was just putting widescreen. Yeah.
Okay. Yes, sir.
Yeah. So I think I need the yeah. If somebody can share the yeah. Dr. Vinod.
1 minute. Yeah, one minute, please. I'm doing that.
Yeah. Okay. Sorry. Yeah, this was a very last minute thing. Usually we don't have a power cut.
It's okay, sir. No problem.
Yeah, thankfully we have the sensor.
Yes, let's do our best.
1 minute, sir.
By the way, thank you everyone for your patience.
Yeah.
This was an emergency situation and we are ready to be patient.
So
Okay, is it?
yeah, I just have to pin your screen, I think.
Yeah, 1 minute because I can disconnect.
Yeah. Oh God, thanks.
Okay.
We got it. So,
Which slide, sir? Okay.
yeah. So you can go down. Yeah. Even more. So you can go to the rational agents. Then I will be telling next slide, we can go there.
Okay.
You can also make this full screen, right? Is it possible to make it full screen?
Actually, it is open. Okay. I think it is open now.
Yeah, even more down. More down.
Is it okay?
Yeah, even down. Thanks a lot, Avinash. Yeah. Yeah. So yeah, even more down. Yeah, this wide is enough. Yeah. So we have to go to the slide of rational agents. 3 more slides down. Yeah, 3 more slides down. We need 3 more slides down. Yeah. It's not yet come. Yeah. One more. Yeah. That acting rational. Next slide. Yeah. Oh, thank God. Power has come.
Okay.
Yeah. No. Yeah. No, not here. The
Is it okay,
I
sir?
think I hope power from my side has come.
Okay, then you
So
can.
yeah.
Yeah, you can proceed. I think.
I will try to share it from my side. Sorry for the.
It's not a problem, sir. So,
Yeah. Sorry. Yeah, it came. I will be sharing again. Okay. So no need to worry.
okay.
Yeah. Yes, we have it. Yeah. Yeah, I think my other link is opening now. Hello.
Audio is not clear, sir.
Now also audio is not clear.
Sir, audio is okay. Maybe some network issues in their part.
Okay, audio is okay. Fine.
Yes,
So
sir.
now
audio
again
is-
I will be sharing because thankfully power came. Okay. So they promised at 12 and I was some 3-4 minute delay and it just I think I am sharing and I will do full screen. Full screen. Yeah. This is good, right? So yes.
It's visible, sir. Okay.
So it's visible. Yeah, we are back to the original thing. Thankfully. Yeah. So what I was saying was AI is basically writing smart programs, but what we are in the setup of what is known as rational agents. Okay, so where we define tasks and what you do is that you define tasks and then you write a program to for the particular task. I think the other thing is still coming, but anyway, let me see. Yeah. So can you see the next slide? So are you able to see the next slide?
Yes, sir. It is philosophy of AI, right?
Hello.
Is it philosophy of AI, sir? Yes,
Yeah.
sir.
So you are able to see the philosophy of AI slide?
Yes,
Yeah.
yes.
Yes, sir.
Okay. So what I was saying is that out of the various philosophies of AI, yeah, thanks, Avinash. So yeah, so the philosophy of AI is now basically acting rational. Okay, so we will not be thinking about whether AI is brain, whether AI has to replicate the way we are doing things, right? So tomorrow you build a chess agent, and then we should not be saying, oh, is it not? It's not playing like Magnus Carlsen. It is not going to play like Magnus Carlsen. Okay, it is not going to play like any human beings. It's going to play in a different way. Okay, so this is also there, and it's also not the fact that you have to store all the details that we know. Audio is breaking now. Is it fine? Hello.
Now it's okay, sir.
No issue, sir.
Okay.
It's okay.
So the photographs are not related to each other. Okay. So those are memoryless models. Then you have hidden Markov model, where in speech you are speaking, the words are related to each other, or a Markov decision process where the probability of occurrence, the next state configuration is depending on the current state and your current action. Okay, what is the next in the next ball? In this ball, wicket will fall or not? Yeah, there is some chance that a wicket will fall, but that depends on the shot you play. And will there be a run scored or not? Yes, there will be some run scored, but it depends on the shot you play and the batsman who is playing the shot. Okay, so all these things are what? Depending, the probabilities depend on the actions. Okay, this slide, one slide. If you understand this slide and the slide where we say that there are only 4 kind of tasks, that is a major understanding. Okay, next. So how do you do machine learning? Okay, this is a very, very simple question. How are you going to do machine learning? So machine learning is basically data-driven model to solve AI task. Okay, AI means it is giving a set of problems. Machine learning is giving us a set of methods. What kind of method? It's a data-driven method. All the data that we have collected from the environment, we just are going to feed it in the computer. Okay, but the computer knows that all this data is coming from some probability model. Behind the data, there is a probability model. Okay, the computer knows that. This is where we are building, right? When we said calculator is not computer, a computer is better than calculator, what does it mean? There is something called a processor. There is something called a loop. There is something called a state machine. You can write program and it can go through a sequence. Similarly, when you are writing AI task, when you are presenting data, we already know that the data is in this format, in the format of the Markovian model, in the format of probability model that the computer knows. That is the understanding. Okay. So what machine learning does is, you have data, you have observation, and it has to take the observation and map it to decisions. That's all. Okay. That's all the machine learning is about. I will give you past data, and then you have to transform it into decisions. Okay, straightforward. Okay, now let us look at what are the 3 kinds of machine learning methods. Okay, usually people teach machine learning by first telling there are 3 kinds of machine learning methods: supervised learning, reinforcement learning, and unsupervised learning. Okay, but what they don't tell you is, they don't tell you for what task this is applicable. Suppose you are going to do prediction, it is called supervised learning. Okay, so all that you need is the 2 things, the data and the label. Okay, what is the observation and what was the hidden state? This is the only thing that you need. In control action, you need something more. In control tasks, which is
reinforcement learning methods are developed for control tasks, you need to know in this state, if I do this, I get this much reward and I go to this state. Okay. So, for example, if I have to train you on, okay, I will show you. This is how we teach kid, right? How do we teach kids? See, this is a stapler pin. This is a pen. That is how we say A for apple, B for ball. This is how we are teaching kids, right? Similarly, that is prediction. So next time the kid will see an apple, it will say apple, apple. Okay, that is just prediction. But if you have to teach the kid, say ride a bicycle. Okay, you cannot just say show a picture of a bicycle and say this is bicycle and this is how you drive it. No, you actually have to make the kid sit on the cycle and then say if you shake the cycle, then you will fall. If you do like if you shake your hips, you will fall. So you have to give the full information. So in control task, it is slightly more harder. Okay. And there is something known as unsupervised learning where you are just representing the data. You are just looking at the information in the data. This is not very critical. So now we will just look at how simple machine learning works. Okay. Very simple part. The simple goal is I want to know how to do linear regression. Meaning I am given these data points. Okay, I am given some x values and y value pairs. So tomorrow, if somebody will give a new x, I have to predict a y. Okay, this is like telling I have told you the cloud photo. I have given you the cloud picture. Okay, and I am telling you, I will tell you, or even very simple, I will tell you temperature and amount of rainfall. Okay, this day this is the temperature and that was the rainfall. Okay. Similarly, I will give you, or I can tell you, this is the weight of a person and y is the height of the person. I have given you height weight data. And tomorrow I am telling you, oh, this person is 5 foot 7 inches tall. Can you guess the person's weight? Okay. This thing I want to learn. So how will I do it? So I can do this, right? I can draw a line like this. This line is not a fit at all, right? It is no fit. It is not at all fitting. This is overfitting the same data because it is exactly doing what the data is doing. This is overfitting. This one is slightly better. Okay. But this looks to be the best fit. Okay. Again, how do we use mathematics to come to this kind of a conclusion? Okay. So how do we use mathematics? This is very simple. So we define a measure of fitness. F of xi is this function. Okay. And yi is the data. We are comparing the difference between the function and the actual value from the data. Okay. If we can do this, we can do this and we can find out how much the function is fitting. Once you know, what can you do? Suppose, let us say we are fitting only straight lines. Straight line is straight line is what? Some constant plus a slope. W0 is a constant, W1 is a slope, and X is the point. Okay. So this is a straight line. And this is the error. So this is the loss. Okay. This fitness measure is a loss function. The loss is a function of W, meaning W is the slope and the constant value. If you give the slope, it will tilt the line like this. If you give a constant, it can shift up and down the line. So what I am doing is I am having the data and I am trying all configuration, shifting up. I want to try all configurations of straight lines and I want to get the right fit, which is in this case is a line which is of negative slope. Okay. So here I use what is known as gradient descent. I take all the data and then I fit the function that I have, and that is a loss function. That fitness, how much is the fitness? I want to do gradient descent. Okay. What is this gradient descent? You just take the derivative of the function. Okay. You just take the derivative of the loss and then you will go to the minimum. Okay. Gradient is just taking differentiation and then going to the minimum. Okay. Second concept, that is totally important is calculus. Okay. So once you form this fitness function, you have to differentiate this function, and then by following the slope, okay, by following the slope of the function, you can just reach the minimum error function, error configuration. Okay. This is almost the workhorse of all machine learning, all of AI. What they do is they take data and then they put the fitness function, and then just they tune these parameters, the slope, right? Here it's a simple model, which is a slope on the straight line. If you are having a neural network, you will have lots of weights. You will just tune those weights and then you will find the best possible fit. Okay. Now, the question is, how good is that best possible fit? The answer is the error, fitness error is, the statistical error is square root d by n. So what is square root d by n? If the parameters, if there are d parameters, for each parameters, so what is square root n? We have to understand where square root 1 by n is coming. So that is the standard deviation. Okay, if you are having n samples, the standard deviation in n sample is square root 1 by n. Okay, for each parameter you have a separate deviation, so you will have this factor of d. So that's how your square root d by n is coming. So basically, when you are taking finite amount of data and you are using a model which is having d parameters, the error in your statistical error, because you are having finite amount of data, okay, the statistical error is of the order square root d by n. Okay, so the second important concept is after probability is calculus, okay, which and optimization, which is basically taking derivatives. Okay, so all of machine learning is just you have a big bag of functions, and then you will have to choose the right function in the bag, and you use machine learning, and that's how you choose. Okay, all of machine learning is just this. So in this, there is something known as algorithmic bias. What is algorithmic bias? You have to choose the right model. Okay, if you choose some wrong model, you will not get the right fitting. Okay, for example, these are lines of positive slope. If you fit lines of positive slope, it's not going to be useful on this problem. What you need is, you need lines of negative slope. This is where the best model is there, right? And you don't also need the squiggly lines because they are overfitting. Okay, if you have to choose the right bag of functions from which you will choose the fitter function. So the algorithmic bias is very important. And the current excitement of deep learning is because somehow we have a model whose weights are tunable, right? So in a linear model, we can tune the slope and we can shift the weights. A neural network is a non-linear model, so you can control the different aspects of the function that this non-linear model is predicting, okay, by tuning its weights. Okay, so you can just think that just like a linear model, this is a non-linear model. Okay, now all that you need is calculus, right, to take derivatives. Okay, so you can take derivatives. What is the if I change this particular knob, particular setting, particular weight in this model, is my fitness getting better or it is getting less? Okay, the fitness has to get better. Okay, the error has to reduce. So you will change the parameters in the direction where the error reduces. That's all. Okay, and how do you know in which direction error reduces? For that you need gradient. You need to know the sensitivity. You need to know the derivative. So once you have the derivative, you can do what is known as back propagation, and you can tune all the weights. Okay, so now there are software systems. So basic concept is just calculus, just derivatives, and then that using the derivative, you are just learning what is the right fit. And why are we excited? We are excited because we are able to solve some tasks which are overlapping. Okay, there are some tasks such as chess, driving, speech, These are in the intersection of tasks that the deep learning can solve, tasks that the humans can solve. Okay, tasks that AI can solve and tasks human can solve. So there is a non-empty intersection. That's why we are thinking in future there will be a lot of tasks that the computers will be able to solve that the humans are solving currently. Okay, so what is the takeaway from now? Takeaway from now is there is a probability model that we are having, and we are having data that comes from that model. If you have the data, we can put a fitness, we can fit the data. Okay, once you fit the data, to fit the data, all that you need to know is calculus. You need to know optimization and gradient descent. Gradient is just derivatives. Okay, once you know the derivative information, differentiation, if you know how to differentiate functions, that's how you are differentiating one function from the other, right? If you change small parameter, the function changes a bit. Okay, if you know the derivatives, you can really write, you can then code it, okay, in a computer, and you can find the best possible fit. Okay, so this is why deep learning is exciting. So if you actually see the progress of AI, right, from long time, initially people were designing communication systems, anti-aircraft missiles. That is like a rudimentary AI. Okay, so if there is a anti-aircraft missile is, there are some bomber aircrafts that are flying. From bottom, we predict and then we shoot a bomb so that when the aircraft is coming, this bomb will go and hit the aircraft. Okay, then we were having basic speech recognition models, which is sequential prediction. Then we were having systems like Deep Blue, where we were doing control tasks. Then finally, we are having stochastic control, where we are able to control even sophisticated systems such as self-driving and playing a complicated game like Go, right? So this we
Excuse me, sir.
Yeah. Hello.
Yes, sir. Hello, sir. Your video got switched off.
Oh. Okay, just
Yes,
a second.
sir.
Let me try to join my own home system because the power is back.
Okay.
And I was on,
It is working fine.
yeah. Now I am on my home system. It should be even better. Yeah.
Sir, it is working fine.
It's working fine. Okay, great.
Yeah.
Okay, so till now, what have we seen? We have seen that probability model is important and optimization theory is important, because which is basically calculus, because all that you are going to do is to fit functions. When you are going to fit functions, all that you have to do is you have to do gradient descent, which is basically see the sensitivity of the fitness to the various parameters in your model. That's all you need. And for that, you need to differentiate, right? That's all we need. Okay. So now we will just see a glimpse of, okay, I'm not going to, I don't know how much time do I have. How much time is left?
Sir, it's almost 30 minutes.
30 more minutes are there?
Yeah.
Yes,
Okay.
sir.
So we are now going to see a little bit about how we are going to solve control tasks. Okay. So suppose the problem is to play chess. Okay. That is the problem that I am having. Okay. This is the problem that I want to solve. Okay. I'm just trying to see where I can keep this. So that I can also work the computer. Yeah, I think it is fine now. Okay. So what we have is we want to learn to play chess. Okay. How are we again using simple probability and estimation to do this? Okay. The algorithm to play chess is known as the upper confidence tree search algorithm. Okay. And this is the basis of, this is the basis of current state of the art game playing AI, right? This is the basis of the current state of the art AI that learns to play games. Okay. So, sorry. Yeah. So now let us see how we are doing this. Okay, in a chess, in a game like chess, which is a two-player game. Okay, there are two players. One is called as the max player. The second is called as the min player. Why these names? This name is because I am white. I am trying to maximize my chance. So because we want some reference, the black will try to
Sir, now your
minimize
voice
the
is
white's
breaking.
chance. Hello? Hello? Avinash, you had to say something?
Yes, sir. Your voice.
Audio not
Your
clear,
voice.
sir.
Voice is breaking. Okay, let me just put it slightly closer. Okay. This is much easier.
Now okay, sir.
Now, okay. Yeah. So suppose in a two-player game like chess. Okay. So there are two players, which is a max player and a min player. Why? The max player tries to maximize its score and the min player is minimizing its score. Minimizing the max player score. Okay. So that we let us understand. Okay. Then what we do is we have alternate moves, right? First the max player will move, then the minimum player will move, white moves, black moves, etc. Okay. And how do we play chess? We say that, oh, suppose if I make this move and suppose the opponent makes that move and suppose then I move this, right? This is what happens in a game. I think that maybe he thinks that maybe I think. Okay, if you understand, I think that if I keep a horse, I think he will keep a bishop and he will think that if he keeps a bishop, I will keep next the pawn. Okay, this is how the game proceeds. This creates what is known as the game tree. Okay, what does the game tree tell you? It is telling you at each step how much branching is there. Okay, from my position, I can make 5 moves. Okay, so there are 5 possibilities. For each of those 5 possibilities, the opponent can make 5 different moves. That means 25 possibilities, right? 25 ways in which when I actually next time I see the board, there could be 25 possible combinations. Okay. So, and I have to know what happens in all of these combinations. I have to think and then I have to play. Great players can think 8 moves ahead. That's what they say. Okay. So now what do I do? How to make moves? Very simple. I will just do some kind of heuristics. I will create this tree and I will see there is a heuristic score. For pawn 1 point, knight 3 point, bishop 3 points, rook 5 point and queen 9 points. Okay. So what I can do is I can go and evaluate the board positions. Okay. So what I have to do, the min player. Okay. So the min player, what the min player will do is the min player will play in a way such that it is the min player will play in such a way that it is hurting the white player. Okay. So what is the white player score? For example, 1 horse in this position, 1 pawn plus 1 horse plus 1 bishop. Okay. Minus the black's thing, it is 3. Here also it's 3. Okay. Similarly, here is minus 9, minus 9. Okay. So what the if you put me in this position, black will definitely play this. Okay. If I play this card, if I put the horse here, black is definitely going to take me to minus 9. Black will not play minus 7. Okay. Black will not choose an option that is easy for me. Black will choose, if I am playing white, black will choose only this minus 9. So I have to just propagate the value minus 9. The score of this is minus 9. The score of this is 3. Okay. And from here, I will obviously choose this branch because here it is giving me 3 instead of minus 9. Okay. This is known as heuristic based search. Okay. The Deep Blue computer, okay, which won against Gary Kasparov, it was using this minimax tree search to search through the board position and make the moves. That's all it was doing. Okay. Fine. So now the upper confidence tree algorithm, which is a learning method. Okay. It is not going to memorize anything. Nobody is telling what is white, what is the worth of rook, what is the worth of bishop. Nobody will tell. Okay. What the learning system will do is play millions of games, and from each position, it will basically take the win-loss ratio. Okay, win-loss ratio. So all that it will do is the upper confidence tree algorithm itself has 4 steps. Okay, all you do is you look at from the current position which of the next moves is leading to more victory than loss. Win-loss ratio you just see. Okay, 7 times out of 10 times I am won. 0 times out of 3 times I have won. Okay, so I am losing 3 times, so I will not choose this. Only 3 out of 8 times I have won, I will not choose this also. I will choose 7 out of 10 times. My opponent, 2 out of 4 times, my opponent has lost. I mean, my opponent, I have won. Okay, so my opponent will choose where I have lost most. So my opponent will choose 1/6 only. Okay, so this is how I will examine my moves. Okay, so just by storing the amount of win-loss ratio, that is the first thing. Okay, then you will go and then you will play the move. Okay, so what happens here? So suppose let us take this. Okay, suppose out of the 3 moves, okay, suppose 3 out of 3 I have won in one router. Okay, because we are making random moves. Okay, in one way 3 out of 3 times I have won, but I have not completely explored. Okay, so truly it is not 100% winning, but it is only 70% winning chance. Okay, in some other place I have made 90 times out of 100 I have moved, I have won. Okay, and the true value is 85% chance. In some other case, experience tells me, data is telling me 99 out of 100 times I am winning. Okay, but the true probability is, true chance is 0.3 only. Okay, because if I play 10,000 games, it will be a fact that okay, only 30% of the times it is a winning thing. Okay, if you see in chess, this opening theory keeps on changing. Okay, this opening, which opening is best, will keep on changing with time, because more and more exploration people do, the value of that opening will go down. Okay, for example, the King's Gambit. The King's Gambit was once upon a time an opening. Nowadays, they know that if you do the King's Gambit, there are standard lines. Standard lines means the opponent can make certain moves and you can just lose. Okay, so what happens is, even though our experience, according to our experience, we are judging sample is 3 out of 3 I have won, 100% experience, it is 100% winning. This is 90% winning, this is 99% winning. But truly, there is the second choice is the one that is best. Okay, so this is something that we have to balance, exploration and exploitation, because we are learning totally from experience. How do you see that? How to balance exploration and exploitation? For example, Alan Border was scoring 0 runs out of the first 7 matches. 0, duck. Okay, but still he became the greatest player, Australian player. He scored 10,000 runs. Okay, that is because they gave more chance. There is exploration. Okay, so again, this is how do we balance this? Okay, so what we will be preferring according to experience. According to experience, 99 out of 100, one choice has given us the best. So according to experience, we will choose that. But what should we actually be choosing? We should be choosing the 90 out of 100, because with more experience, this is going to be the best. Okay, so how do we do this? That is the question. So this is known as the multi-armed bandit problem, where you balance exploration and exploitation. So what we can do is, we cannot say that, in order to learn about some option, we have to play it infinitely many number of times. But at the same time, if you have to try the suboptimal options only logarithmic number of times. Okay, this is the idea. So let us see how this works. Okay, So we have to choose the sample mean, which is the estimation from the past, and a bonus, exploration bonus, which is square root log t divided by number of times we played. If we use this rule, we are able to choose the best decision. Okay, let us see how this happens. Suppose there are two arms. First choice is best. Okay, first choice is the mu1 is high and the mu2 is low. Okay, now suppose I am picking some samples. So first sample I saw from the first option is happens to be lesser than the second option. Okay, so I have to keep, so suppose I fix this, only one data point I have seen. Just by playing some few games, if I have to decide on one action, it is wrong. Okay, so first few games, first option is turning out to be bad compared to the second option. So what do? I put this exploration bonus and I see what is the best. Okay, here mu2 is coming out to be the best. That's okay. I will choose the second one. Okay, but what happens as you keep choosing the second one, this interval, this confidence that we are having, we lose confidence because we are having less number of samples. Here the confidence increases because we have more number of samples. So what happens is, once we have less confidence on the least sample, we will give more chance. Okay, so then you will give arm 1 the chance. Then this will pick up, and we know that if we get infinite number of samples, we will always converge to the right answer. Okay, all that we have to avoid is, we should avoid the place where, because there are less number of samples, we made a wrong decision. Okay, so all that you have to do is, if the samples are less, you have to give benefit of doubt. Okay, this is known as optimism under uncertainty. You give benefit of doubt and then you choose, you give chance. Okay, you give chance to the failing things, but you don't give always chance. You give logarithm number of time chance. Okay, out of 10,000 moves, 10,000 trials, log 10,000 times, I will try the bad ones. Okay, suppose if it was truly a good one, and suppose there are some initial samples were wrong, by giving this logarithm trials alone, I can recover. Okay, this is again purely coming from probability theory and interval estimation. All that you do is, you estimate and you estimate an interval. Okay, in statistics you always estimate the confidence interval. Just by estimating the sample mean and the interval and using the value which is the best possible, you take the best possible in the interval and you play that action. That itself is enough to learn to play chess from scratch, to learn to play a game such as Go from scratch. Okay, win or loss ratio plus confidence interval, that is enough. That is the engine that is allowing us to play a game like Go, right? So what you do is, you have this kind of games, game tree. Instead of heuristics, what you do is, you actually play till the end. Okay, you play till the end. You just don't put some heuristics. You play based on experience. Okay, but as you keep playing, okay, as you keep getting data, you store it in a neural network. Okay, you store it in a neural network so that you fit a function. Okay, then the neural network will start predicting, right? It will start predicting which of the actions to play. Okay, so this way you don't have to see all the board positions. Okay, because with the amount of board positions you have seen, you are already training a neural network. If you have trained it sufficiently, future board positions, it will be able to play on its own. Okay, so this is the idea. Okay, so what is the idea? Idea is of probability. How to tune a network? Again, the idea is that of calculus. How to learn from samples? Again, the idea is that of estimating the sample mean and the confidence interval. Okay, so this is a reinforcement learning algorithm. Okay, so do we have more time, or should I stop here and we have to take questions, or how do we go from here?
Sir, there is a doubt clearance session.
Okay.
If the participants need to ask some questions, they can ask.
Okay. So when does it start from? How long can I go? Or
You can decide, sir, no problem.
hello?
Yes,
Hello?
sir.
Yeah. So how long can I go?
It's okay, sir. You can decide, no problem. If it is
Okay.
over, we can ask the participants for the doubt clearance.
Okay. I will do only one more small topic quickly. Then we can go for doubts.
Okay, sir.
Okay. Okay. So this is, or I think it is better we stop here because I don't want to confuse people. Let us stop here. I am not going to do Markov decision processes. So let us stop here and then we can go for doubt clearance. And in doubt clearance, I will be able to answer more than just this. Yeah. Hello. How many software are we going to use for AI? Okay. So I am seeing this as pop-up, but yeah. Okay. How many software are we going to use for the AI? This is Daha Sehu. He is asking this question. Okay. So AI itself. Okay. Currently, we need what is known as TensorFlow, which is basically based on Python. It's TensorFlow. What it is doing is I am just showing in the screen. Okay. So all that TensorFlow is doing is just this, what is known as automatic differentiation. Okay. So you have a neural network, okay, which is a nonlinear function, and you want to find the derivative. Okay. You want to find the differentiation, the derivative of the output with respect to the images. So with respect to its not the images, you have to find the derivative of the output with respect to the weights. So you take the derivative and then you can propagate via chain rule. Okay. So the only software that it is doing is it is going to do automatic differentiation. It is going to implement the chain rule of differentiation. That's the only software. So see, the second question is, AI is a boon or a it's a bane, right? We see, is it going to result in job losses? See, this is the same thing that people worried. If you have computers, you will have job loss, but that's not the case. We are having more jobs because of computers. Okay, the same thing will happen with AI. Okay, we will learn more. Okay, so until because we will be able to do the standard things, we will have more time to do creative things, right? Just like we had it is any technology. Okay, we had machines, we had train. Because we had train, we had aircrafts, we didn't have job loss. We had mechanization, mechanical engineering, we did not have job loss, right? We had more jobs. Okay, so there won't be job loss. That's number one. Okay, and somebody is asking, what are the use of AI in pandemic period? Okay, so here again, AI, when we say AI, we are just saying data driven methods, right? We are looking at data, and with data, so we what we are going to do is to learn the patterns from data. So it can give us some understanding of how the virus itself is. Design of the drugs, there is AI. AI is used in design of drug discovery, right? So that way AI is used. AI can be used in the way in which the pandemic is spreading. The spreading pattern we can try to predict. Okay, this is where the AI can be used. Okay, so yeah, so first order logic. So we have kind of walked away from this logic based systems, and we are just designing these neural network based systems. Okay, so the logic based system is inference. So you will say that A is true, B is true, then what? Is C true, right? Those kind of systems are not scalable for real time tasks. So current AI systems are not logic based, they are basically rational agent based and task based. Yes, so automatic theorem proving it's there. Okay, automatic theorem proving it's there in the conventional AI paradigm. Okay, this Lisp and then the conventional AI paradigm. So where you treat that the theorem prover itself is what you start from a statement and then you make a set of statements and then you guess the number of statements and then you say that okay, the theorem is proved. We can train some of these people are training these machines by giving the past theorems, right? And then they're saying that okay, can you prove new theorems? That effort is there, but yeah, that's really not the place where AI is found powerful. Current AI is powerful on tasks such as these images, signal processing. Anywhere there is signal processing, we have been able to replace it with this kind of AI systems. Oh no, the statistical error can never be zero because you have finite number of samples. So the statistical error is always zero. Okay, so somebody is asking, what is the difference between deep learning and reinforcement learning? Okay, reinforcement learning is a method for control task. Deep learning itself is a function. It is a non-linear function. It is a function generator. For each weight, it is giving a non-linear function. That's all deep learning is. Okay. And deep learning means how do you encode the information inside this box? Okay. Artificial neural network, deep network itself is like a black box or a box, and we want to tune the weights so that we want to get the right output from the box. That is what is deep learning telling us. Reinforcement learning is telling how to solve control task. Okay, so I can have a model which is not a deep learning model. I can still do reinforcement learning. Okay, reinforcement learning is geared towards, so I can combine reinforcement learning and deep learning to do what is known as deep reinforcement learning. Okay, and I can do reinforcement learning without deep learning, and I can do deep learning for something like supervised learning. There can be supervised deep learning. For example, classification of images. That is deep learning that does not involve reinforcement learning. I can just do reinforcement learning with a linear approximator or a simple tabular column kind of approach. There I don't need deep learning. Okay, so this employment or AI to be more than the human mind. See, all these things are very far away. What we are looking at is the task-based approach. There are some tasks. Can I solve the task? This is all I want to know. Okay, that's all I can actually think of doing at this point of time. So yeah, so the programs themselves cannot get better. See, again, calculator to computer, it's a conceptual leap, right? Programming is the conceptual leap. From computers, from program to AI, the conceptual leap is this rational agent framework, right? That you can model everything, every task as in terms of probabilities. And once you model everything in probability, you can talk about data. Once you have data, you can train from data. See, that is the paradigm. The paradigm is that of machine learning from data. The program is learning from data. That is the conceptual shift. Okay, so already, yes, it is a program that is changing itself. Okay, from data. Okay, will it reach human level ability? That is so far ahead in the horizon. Yeah, so what is the mathematical justification? So the mathematical justification currently is just the statistical guarantee. The statistical guarantee is if I have seen enough number of samples, then I would have fit the right curve. Okay, that is the statistical guarantee. So we are working in the statistical paradigm where we see that the data is coming from some set of samples. So there are different paradigms which are not statistical paradigms. They are there. So there we are, the same things will not hold. So that's still an open thing, right? How much guarantee is there for all these AI systems? That's still open, right? Yeah. So you can keep asking more questions. What is fuzzy logic and AI? See, this fuzzy logic also people tried, okay. It was just a very, it was not using the probability model. The tasks were not modeled. The learning from data, that is not modeled. So the fuzzy logic, so if you look at the machine learning research itself, before the 1990s, okay, people were doing fuzzy logic, genetic algorithms. They were doing what is known as thinking like human, okay, mimicking humans. These kind of AI approaches they were doing, which is not, which is using mathematics, but not completely based on current AI systems. Current AI systems are more mathematics based, like they are founded on probability theory. Foundation is probability, and the tools you are using calculus to build optimization algorithms. So this is the missing part, okay. So once you start using mathematical tools, the scaling, the number of problems on which it will work will increase. That is why the fuzzy logic is no longer used. Things like neural networks, differentiable architectures, they are getting used. Assessment of students using AI. Okay, so AI for education is something that even we are working on. Okay, so people try. So people are trying. Can you do something with grade prediction? With predicting the grades of the students, can you actually go and tell them whether can they do some more lessons, etc. So yeah, application of AI to education is also another field. We are some of which even I am working on. So yes. Yeah, so Markovian model is always violated, okay, because the Markovian model needs the past states, right? So not every state we can model actually, okay. Sometimes when we don't have access to all the states, then it does not become a Markovian model. So what you have is a hidden Markov model, okay. So then that happens. So yes, so the Markovian is a assumption, but it's an useful assumption, right?
One more. Feedback link. One more.
Excuse me, sir.
Yes.
Sir, there are some questions from YouTube live streaming also. Can I read?
Okay. So how do I do it?
Yeah, I shall read it for you, sir.
Okay. Yeah, sure.
Yes, there is a question from Krishnasamy R. Can you tell the advantages of machine learning over deep learning?
No, deep learning is also a machine learning method actually. So it is not anything different from it's one method, one way of doing machine learning, which uses a neural network. That is all it is. So yeah. Hello.
Okay, sir.
Yeah.
And participants can ask their doubts by unmuting also. That will
Yes.
be more helpful for speaker to answer your questions.
Hello. Hello. Am I audible?
Yes, Sri Lakshmi, you are audible.
Okay. So I'm Sri Lakshmi. I'm from Malabar Christian College, third year BSc Maths student from Kerala. Compared to olden days, we have started using these computers, social medias on a rapidly increasing rate. So we have changed our classes and all to online. So there is a change in our ethical concepts and also. Can you share your views about it?
Okay, so this is something that I care about very deeply. The thing is, previously when we were doing, so I don't know whether you are aware of this Salman Khan, Sal Khan, who is the founder of this Khan Academy. Okay, so which is basically giving online lectures to students. Okay, he has created content for all classes. Okay, so what he says is that as we have more and more technology, human beings will move into the creative sphere. Okay, we will get more and more time for doing creativity. Okay, now there is say this content, right? So increasingly I see that the classrooms will go into what is known as the flipped classroom mode. Okay, which is the instructor will record a lecture and people will actually see the recorded lecture. Okay, and if in fact some points are left, I can go and edit the recorded lecture, and then you see the recorded lecture, and we use the session. Okay, we use the session, any teaching session to discuss the doubts. Okay, and in general there are 4 components to learning. One is classroom learning, number 2 is what is known as self-learning, number 3 is what is known as peer discussion, number 4 is learning.
Not audible, sir.
Hello, maybe I am muted myself. No, I am not muted. Yeah,
Sir, it's not muted, but the voice is breaking somewhere.
Oh, voice is breaking. Hello, now?
Yes, sir.
Now audible, sir. Now audible.
Yeah. So there are 4 parts. Okay, the 4 parts being one is self-learning, one is classroom learning, next is self-learning, peer learning, and learning with over time. Okay, now from the olden days, the olden days is basically classroom-based learning.
Sir, again the voice is decreasing, the sound is decreasing, sir.
Hello, yeah, the olden days the learning is basically classroom-based learning. Okay, and in most cases, what? Hello, can I try with my computer?
Sir, let me give you a suggestion. Are you putting your fingers on the mic?
Oh,
No.
Maybe that is the case. Hello, hello.
Now it's clear, sir. Now it's very clear, sir.
Yeah,
Maybe that is
that's
the issue.
Yeah, correct.
Okay.
Good, thanks.
Yes.
Okay.
Thank you, sir.
So,
Okay.
yeah. So what's happening currently is, see, previously what we were having was just classroom learning, self-learning, and venues for self-learning and venues for peer learning, discussion, and learning over time. This was missing. Okay. So now because of this technology, we are going to see a trend in what is known as flipped classroom. What you do is, the content itself will be recorded. Okay, and there will be multiple contents. So many teachers will be recording and putting online. Okay, instead of books, you will have lectures, video lectures. People will see it. Okay, and now what happens? Now it is self-learning. Okay, each student can then ask their particular doubt. The classroom will be for particular doubts. Okay, so this way education will get personalized. Okay, different kind of doubts we can learn, we can utilize the time. Then we will have peer discussion. Okay, I am foreseeing a future where, like Orkut used to be there, like we have Facebook now, you are going to have something like a Facebook of academics. Just people are going to do academics. There is going to be TikTok of academics. This is something that might happen. Okay, in the future, right? People will put explanation videos on small concepts, and then you can just click those small concepts from school to say college. Okay, this is going to happen. Then again, how do you curate this content? Okay, which content is good, which content is bad? There AI is going to help. Okay, AI is going to also help in recommendations. Okay, where you learned some 2-3 topics, then can I recommend you a new topic, just like a movie? Okay, so these are things that are going to happen. Okay,
So it's not going to just affect us. It's just going to simply going to even help us. Okay. So that is my answer. So somebody has asked.
Yes, sir. Some more questions from YouTube live streaming. Since they can't ask directly, can I read it?
Yeah, sure.
Okay, this is a question from Martin George. What is the best way to study artificial intelligence? A 3 or 4 year degree course in AI, or after degree in one subject and then doing a PG course?
Okay,
This is
so
the question.
currently the BTech in artificial intelligence is kind of offered only. There is a BSc in data science program by IIT Madras, and I think there is a BTech program on artificial intelligence by IIT Hyderabad. But we should be telling, I am glad to tell you that we have our own MTech in data science, okay, where you will be learning AI, right, and data science at IIT Palakkad. But this is an MTech where you have to write GATE and you have to come via GATE. But all of the important institutions in India are having a PG degree definitely in artificial intelligence. So that's there. So directly a BTech program, it's only available in few places. But as a post-graduation, machine learning or artificial intelligence, it's available in almost all the institutes in India. So there is no issue there. So yes, it's up to, so if you have any foundation in any of the basic courses, it doesn't hurt. You can still get a PG program in AI. Yeah. So a couple of more questions were there even in this, what do you call, this chat box. So one is, yeah, so I will just answer it and then you can take YouTube questions. So one is on the large amount of training data. Okay, so training data, see, this is where the AI wins, right? So neural network, you always have vision data. Vision data is not a difficulty, right? You always have vision data. Okay, you just put a camera, there is so much amount of vision data. That's not a difficulty at all. In fact, even tagged data, right? Vision data being tagged, even that's not a issue, right? Because people are even tagging a lot of images, Facebook images. So yes, it is data hungry, but the current world is also data rich. Every sensor, right? If you take a car, there are, so many sensors in a car, and they are actually producing a lot of data. If you look at satellites, if you think about amount of data, it is almost producing, I think, GB of data, 1 GB of data per day. I think that's the guess. So this is the satellite data that we get on the clouds and the rainfall data. I mean, so with which you can figure out how the atmosphere looks. So the data is huge. So we only need methods that will catch up with this data. Okay. And somebody is asking Monte Carlo simulation. Yes, all of these things, right? So the tree search, the initial tree search itself is called Monte Carlo tree search. Monte Carlo in general means you are going to take samples and you are going to learn in terms of samples. Yes, you are having already Monte Carlo methods, AlphaGo, AlphaChess, everywhere. You can say that it's a Monte Carlo method in that it is using a simulated sample. You simulate games basically. So it's still a Monte Carlo method. And programming knowledge, yes, it is mandatory for AI. You have to be able to code in Python, TensorFlow. Yes, programming is definitely important. Yeah, so back to Arjuna. We can take some more questions from YouTube.
Yeah, sure, sir. This is a question from Deepika Joshi. How PG mathematics student do a career in AI?
Okay, so either they have to take a course in AI by doing some kind of from one of these premier institutes, or the other way could be they can target some of these companies, such as there are who are looking for data scientist positions. Okay, and they take in candidates from the science stream. Okay, for example, CTS has its own data science team, I believe. Verizon has, Infosys has. So that could be another way in which you get into data science. Anybody in statistics, they can get into data science. So basically, you have to get into jobs, okay, which will have a data science role. And there they, in general, any of the technology jobs, they are welcoming for mathematicians. Programming plus mathematics, if you have that background, you can find yourselves in any data science role in with any of these firms, right? So that could be a way in data science, and after that you can get into formal programs. Most of these institutes are also floating, corporate level AI courses. That's also happening. That is there, and you can also do courses in Coursera or open source forums where you can register for these courses. Yes, that's also possible. Yes. Yeah. So,
Okay, thank you, sir. Can I read some more questions?
Yeah, sure. Yes.
This is from Irana Bandari. Is there any career opportunities for physics?
Yes, also physics and maths, chemistry. See, all of this has the necessary essential tools, right? But you might have to upgrade it either via a PG program, or if you have a programming background, you should try to find a job in a firm which has a data science position, and you should try to market yourselves as a data science person. You can register for some of the courses, machine learning and AI courses via Coursera, right? And you can certainly try that.
Okay, thank you, sir. This is a question. Yes, sir.
Yeah. Sure. Yeah. Go ahead.
This is from Ajit Kumar. Sir, please explain perspectron converges theorem in geometrical meaning.
Oh, okay. So that's okay. So let me see whether I have. This is something that I have done in my classroom. Okay. So I have to check for those slides. I think I will have. Yeah, I think I have this. Okay, so yeah, so the geometric, okay, so I will share the screen. Maybe just let us see this. Can you now? I'm going to present. Sorry. Right. So yeah, so the proof idea is as follows. Okay, so what you try to do is you have the crosses and dots. Okay, and this is what you want to separate. Right. So what you can think of, the data set contains crosses and dots. This is same as a data set that contains the reflected. So if you draw a line through origin, okay. So I am answering to the question by a person who has looked at the perceptron algorithm and is searching for the proof, a geometric proof. Okay. So what you can do is you can always, reflect the data. Okay. And once you reflect the data, then it is just trying to, learn the separation, which is this straight line. Okay. So all that you are going to do is to, I don't have them here yet. So the key idea is reflection. So I think, yeah, I have done it in my class, but I don't have necessarily the slides here because I did it in Blackboard. So what you can think of it is, you first move the data on one side, okay, on one side of the axis. Then all that you are trying to do is you are trying to go up and down, and eventually you will learn the line that separates the two data sets. right? So you can think of it that way. Okay, so other than that, to give a elaborate mathematical, geometric proof, I think I have to separately do a session and release a video. Okay, so that is something that I am also thinking. Hopefully that will happen in the future. Yeah.
Okay, sir. This is another question from Trinath Prasad Pati. Okay. CBSE has introduced artificial intelligence from class 6 to 7. What is the minimum requirement to understand it by the students?
No, see, everything you can break it down in simple terms, right? So there is, if you look at actual physics or chemistry, at the highest level, you would need almost all the sophisticated mathematical tools to understand. Okay, but then you still start chemistry by saying that, okay, there are some compounds, there are some, organic, inorganic, you try to classify, right? One could definitely teach some of that to the school. I have done a session on AI at the Calicut Planetarium, and the youngest audience was standard 9, and I was able to get across to that student to some amount of success. Meaning it's based on what you are going to tell them, okay, and how much you are going to simplify the concepts, and at what level you are going to tell, right? So yeah. That's not an issue. The student prerequisite, the standard at which you are going to tell is not an issue. The issue is to design a careful curriculum that will tell them the essentials in a way they can understand.
Okay, sir. I hope there are no more doubts. If there is any doubt, the participants can give it in the chat box or unmute and speak. Otherwise, we are winding up today's session.
Yeah, only one more question was there. The one question by Amrita is, what programming knowledge? You should definitely be knowing Python. Okay, should definitely be knowing Python, and yeah, that is definitely an important thing. Yes. Yeah. Yeah.
Okay, sir. Yes.
Any course in Python. I really do not know separate courses in Python. The Coursera should be having something. There will definitely be a lot of online lectures, right? So you can almost type introduction to Python in YouTube. There will be, I am sure there will be hundreds of courses. There will be definitely 2 of them that will be very useful. But more importantly, you should try to do it on your own. Okay, that should be the idea. Okay, so yeah.
So I'm hoping the questions are over, and I'm really thanking you, sir, because you took the patience and pain to answer each of the question very slowly, and the session was really fruitful one. I hope all participants also feel so, and I thank every participants also for the interactive session, and especially to Chandrasekhar Lakshminarayanan sir on behalf of the organizing team and everyone who is present here. I am expressing my sincere love and gratitude. Okay, sir. And I would like to invite Anna Mary, third year BSc student from St. Joseph College, Devagiri, to deliver a formal word of thanks for our session. And after that, we will be winding up our webinar. Those who didn't fill the feedback forms, please fill and kindly get your e-certificates. Okay, thank you all. I like to invite Anna Mary.
Am I audible?
Yes,
No?
you are audible. Yes, it's audible.
Good afternoon to one and all. Respected resource person, Dr. Chandrasekhar Lakshminarayanan, the main organizer of the program, Dr. Vinod Kumar, other team members, and all participants. I'm really overwhelmed to propose a vote of thanks for this session. Artificial intelligence is something that we come across on a daily basis without even knowing what it really means. And as Rajivan sir said in the beginning, at this present scenario, when we are living in a world surrounded by digital, digital world, this topic is highly relevant. And today, through this wonderful session, we came to know about the possibilities of artificial intelligence as well as what it means to our future. And we are really thankful to you, Dr. Chandrasekhar Lakshminarayanan, for explaining this topic with such ease that we were completely into the topic. And on behalf of the team, and as well as on behalf of all the participants, thank you for your effort. And coming to the participants, we have participants from various parts of the country, as well as participants from other regions too. And many have joined in the Google Meet, as well as others are watching in YouTube Live. And the active participation is what makes a webinar success. And I'm thankful to all of you for your participation and cooperation, and for all your patience for during the time of a small power failure. All of you were calm and patient. Thank you, each and every one of you. And we all know the efforts Dr. Vinod Kumar has put forward to make this venture a success. This is the second webinar on the series after the first one on cybersecurity and mathematics. And Vinod sir is managing Math Aspirants WhatsApp group, as well as the Google group for online test series. He's doing great efforts for the students community. And we are all really thankful to you, sir, for all your efforts, support, and encouragement. I would like to thank Dr. Biju Monar for all his efforts and technical supports from the very beginning of the program. I would like to thank the members of CDC Perambra and also to Rajivan sir for hosting this program, and as well as for all their support. Now I would like to thank all the members of the organizing committee, including especially Ms. GROs and Ms. Anne-Marie Tony for being with the program from the very beginning and for giving us such a wonderful experience. I would also like to mention our anchor, Ms. Arjuna MP, for handling this session very beautifully and also for managing the situations so peacefully and patiently. I would also like to thank the members of the Math Aspirants WhatsApp group for their active participation. And pardon me if I have forgot any names. And once again, thanks to each and every one of you. Thank you.
So thank you all. Thank you, Anna. We are winding up our session, webinar. Thank you, everyone, once again.
Okay. Thank you, Chandrasekhar sir. Thank you very much.
Thanks, Dr. Vinod. Thanks for the invite. I hope there was a slight hiccup. I was having my heart in the mouth. Luckily, the power came.
It's okay. This type of sessions may happen. This type of things online. There are many non-predictable things may happen during such a online session.
Thank you, sir. It was a wonderful experience.
Thanks a lot. Thanks.
Okay. Yes, great effort.
Yeah, thanks.
Okay. Okay. Thank you. Let us wind up. Okay.